yet another class. I'm Dr. B, your chemistry teacher, and today we are going to be discussing stoichiometry. Stoichiometry is quite a very common word that we hear every day, but interestingly, we do not come to terms with the interpretations of that word, stoichiometry. So today we are going to ask ourselves what stoichiometry is all about and what area is it actually being applied. Now I want us to know that stoichiometry can simply be put in a one-time amount. Now, when you say stoichiometry of a particular reaction, it means you are trying to look for an amount of reactant that gives you an amount of product in a balanced chemical reaction. That means you cannot talk about stoichiometry without talking about a balanced chemical equation. If your chemical equation for that reaction is not balanced, then you will not be able to get the proper stoichiometry of that reaction. That means that if you carry out a reaction, you must be able to balance the amounts in terms of the reactants, if it is moles or in grams as the case may be, and also balance that in terms of the product before you can talk about the stoichiometry. So stoichiometry is simply the amount of reactants or products in a balanced chemical reaction. And if you take a look at this chemical reaction where we have iron reacting with 4 moles of water to give us iron 3 oxide and hydrogen. Now, if you are looking at the stoichiometry of this reaction, provided the reaction is balanced, and of course the reaction ought to have been balanced because you have 8 hydrogen and 4 oxygen, and here is also 4 oxygen, 8 hydrogen, and 3 molecules of iron. Now, if you are looking for the stoichiometry of this reaction, that means you are looking for the amount of reactants and products in this balanced chemical equation. The relevance of this stoichiometry in chemistry is to allow us be able to calculate either in moles or in grams or even in volume the amount of reactants that actually reacted to give you a certain amount of product. So you'll be able to calculate the amount of substance in the reactant that's involved in the chemical reaction and the amount in terms of product that is obtained. That is the yield. Now, if we are looking at the stoichiometry of this particular reaction, now in moles, let's first say we are looking at it in moles. Now, I want us to know that the interpretation of this reaction is that 3 moles of iron, okay, reacted with 4 moles of water, okay, to give 1 mole of what? Iron 3 oxide and 4 moles of hydrogen. Okay? Now, this is the stoichiometric interpretation of this equation that we have here in moles. So it means that you reacted 3 moles of iron with 4 moles of water, and it yielded what? 1 mole of iron 3 oxide plus 4 moles of hydrogen gas. In this reaction, all the reactants, we have solid, we have liquid, and the product we have solid, we have a gas that is being given out. Now, this is what we mean by stoichiometry. Simply, amount of what? Substance in a balanced chemical reaction, amount of reactants, and product in a balanced chemical reaction. So when someone tell you what is the stoichiometry of this your standard solution, the person wants to know the various amounts you use to produce that standard solution. That is just the English stoichiometry. Okay, now what if we are looking at this? What if we are looking at this in terms of mass, in terms of mass, we have looked at the stoichiometry in terms of what? In terms of volume. Sorry, in terms of moles. What if we are looking at it in terms of mass, which is the ideal? Now, in terms of mass, we want to know how much quantity in grams, because this does not tell us anything about grams, it's just the mole. But in grams, how much quantity of iron was actually reacted to give us iron 3 oxide? Now, in that case, we need to understand what the molecular masses of these particular compounds are. Now, in that case, it means that we will say 168 grams, which of course is 56 times 3. That means that this is of iron. Okay. Now that means the mass of the molecular mass, of course, of iron is 56. Multiply that by 3 moles, it gives you 168 grams of iron. So when you see 3 iron, what it means that 168 grams of this iron is what was used to react. That is stoichiometry. Alright, so it means that it was reacted, okay, of iron, reacted with what? Reacted with, let's say, okay, 72 grams, which is 18 times 4 of water. Of course, 18 times 4 means that the molecular mass of water is 18 times 4. It gives you what? It gives you the mass of water that was used to react with 168 grams of iron. So now we can say 168 grams of iron. In terms you wanted to prepare this particular product by this reaction, this is where you have to come in. This is where the stoichiometry works. So it means that you have to measure 168 grams of what? Of iron, react it with 72 grams of water, and it yields what? It yields, if you take a look at what we have here, it's if you look at the molecular mass of this is like, say, 1 times 8 molecular mass, and that will give you about 231 grams of iron 3 oxide, and what? And of course 8 grams of water, of hydrogen rather. Now this is what stoichiometry is all about. Stoichiometry is all about understanding the various amounts of the reactants that actually reacted to give you products. And what amounts in a product are we talking about? So if we take a look at the stoichiometry in terms of mass, what it means is that if I must prepare this, I have to measure 168 grams of iron, react it with what? With 72 grams of water, which is 4 times 18, which is the molecular mass of water, to yield 231 grams of iron 3. This of course means the whole of this iron 3 oxide, if you look at the molecular mass, it gives you 231 grams and 8 grams of hydrogen. Now with this, you'll be able to know if you are going to have a valuable yield at the end of the day or not, if the reaction is going to favor positively the right hand part, which is the product, or is going to favor the reactant at the end of the day. So stoichiometry gives you a light to understand how you can actually produce anything you want to produce, any company you want to produce, okay? And it allows you to understand whether the production will yield positively, favoring the favoring the product, which is at the right hand side, or is going to favor what? The reactant, which is at the left hand side. Now I'm sure that today you have understood what stoichiometry is all about and how we can determine stoichiometry from a particular chemical reaction. And remember that that reaction must be a balanced equation. Now let us take a look at another one very briefly. Let's take a look at another one very briefly. Now, if we take a look at this kind of reaction that involve gases only, Okay, it involves gases only. You will see that we have a typical reaction like, okay, a CH4 gas, this methane gas. Okay, now it's reacting actually with oxygen gas, and this actually gives us a CO2 gas plus water in a gaseous form. Now if you take a look at this reaction, you will notice that this reaction has much to do with what? With gases. Where you have gases, the stoichiometry or the amount you calculate for gases depends on, seriously, on what? On the volume instead. Now you need to understand that if you are calculating stoichiometry for gases, 1 mole of any gas at all, 1 mole of any gas at all is equivalent to 22.4 liters. Okay? 1 mole of, you must take note of this, that 1 mole of any gas at all is equivalent to 22.4 liters. So if you are calculating stoichiometry for a reaction that is all gases, both the reactants and the products, you must understand that you are equating 1 mole of each of the gases here to 22.4 liters. That is what makes it different from the stoichiometry of the first equation, which was in a solid and liquid. Now, it means that if we are taking the stoichiometry for this, it means this is 1 mole of CH4, methane gas, because there is nothing here, so it's 1 mole. So we have 1 mole times 22.4 liters. You see? That's what you have. And then plus 2 moles times 22.4 liters. It will give us what? It will give us 1 mole. 1 mole times 22.4 liters. Okay? Plus 2 moles times 22.4 liters. Do you see the difference here? The difference here is that we are considering 1 mole of every gas equivalent to 22.4 liters if you must calculate stoichiometry of reactions that involve only gases. You must take note of that. So in that case, we are going to have what? 22.4 liters, okay, of what? Of, okay, 22.4 liters of methane gas reacted. Okay, it reacted with what? Reacted with 44.8 liters of what? Of oxygen gas, okay, to yield what? To yield another 22.4 liters of what? Of CO2 gas, and what? And 44.8 liters of what? Of water. So in the stoichiometry of gases, this is how it's going to look like. You are equating 1 mole of each of the gases to 22.4 liters and use that to determine the stoichiometry. So if you were going to prepare this kind of, you are going to prepare this, carry out this kind of a reaction, to prepare this, you are going to need 22.4 liters of methane gas reacting with 44.8 liters of oxygen to yield 22.4 liters of oxygen, and that of what? Sorry, this is not, okay, CO2, and then 44.8 liters of water. So with this study today, you should be able to take a look at different chemical reactions and be able to determine their stoichiometry. And when you enter the lab and the word stoichiometry comes, you should understand that it's only talking about the amounts that were used in the preparation of whatever standard solution or any kind of reaction that, any kind of solution that you had prepared already. Beautiful class, I suppose. Please do not forget to share Do not forget to subscribe at my YouTube channel, Dr. B Chemistry Classes. Do not also forget to leave your comments either in question form or in any other form. It will be attended to. Answers will be provided. Don't forget to also visit my Facebook page, Dr. B Chemistry Classes, on my Facebook page, and share, like, and comment. Until next time, it is a bye.